Welcome to a brief lesson just to review some of our key aspects of analyzing variables. And when I say that, that's a ton of like all the questions that we ask. In physics, we're really focused on, hey, if I make this change to one variable, what happens to this other variable? So we have a typical example with a question here. If we double the length L of a pendulum that has a period T, how will the new period compare to the original? And notice that there's a few things that are implied as far as what you should already know. You should know that length is relevant to the period of the pendulum. You should know, as opposed to the mass, for example, of the pendulum. And you should know something about the relationships that these variables have a relationship. And most important, you should know or be able to find an equation that defines that relationship and know what to do with it. Now, again, in physics, it's not about memorizing these. It's about being able to find the information and sift through what's relevant and be able to produce information from that. That's actually the skill that we're focusing on. But we're using pendulum and period because, hey, we've been doing that with simple harmonic motion recently. So, for example, we can look on the equation sheet to get that period t of a pendulum is 2 pi of root L over g. There's a couple equations for period for simple harmonic motion, and we have to know that this is the relevant one for a pendulum with length L and gravitational field g or gravitational acceleration g. So we have to know that, hey, we don't expect the gravitational field to change unless there's something really weird going on or we've gone to another planet. Now, second, we should be able to quickly analyze and tell whether this is a direct or inverse relationship. Because notice we have 2t between t and 2t. It will remain the same. So will it get larger? Will it stay the same? Will it get smaller? So in an equation, what is my key unknown here? I am being asked to make claims about t. So I want to make sure that that variable is alone. If it's not already alone, we need to get it there. So, okay, in my equation, that variable is alone. Second, so my other variables across from it, the relevant variables are L and G. Well, for practical purposes, G is not changing. L can be. And in fact, we know that we have doubled L. Well, T and L, they are one across from each other in the equation, and two, they're both on top. And this tells us that it's a direct relationship. So, if L is doubled, then that means T is also going to go up. L goes up, T goes up. That means we can get rid of all of these answers. And I put this in a multiple choice format, but you've already seen ones where you would have to be able to explain, even if you didn't have multiple choice answers, you would need to be able to explain this. And so we're going to show a form for one, being able to come up with it for yourself and show work, or two, to actually something you can use in justification in a free response problem. You know, it could easily be explain how you know what the new period would be. Okay, well, they didn't give me numbers, so how am I supposed to calculate that? You know, they just told me a length L and a period T, and my new length is 2L. Well, this is where we're going to go to fill in the blank analysis. Fill in the blank means I'm looking at my equation, and I'm just putting little blanks in front of every variable. I don't put a blank in front of the 2 here. I don't put a blank in front of the pi. Those are staying the same no matter what the pendulum is, no matter what the length. These are universally true. They don't vary. So I don't put blanks in front of them. I put blanks only in front of things that can be variables. We've already discussed how gravitational field, unless we're leaving Earth or something very bad is happening to planet Earth, G isn't going to change. So I put a 1 in front of that. 1 means it hasn't increased or it hasn't decreased. Multiplying G times 1 doesn't change it, as opposed to multiplying L times 2. Oh, we have 2 times L. We have doubled the original, the old length. So what we're being tasked with figuring out is, okay, what is the new period? We're already predicting that the period is going to go up, but that's the most basic of questions. How much is it going to go up? Well, to do that, I can look at my ratios over here, but I have to pay attention to what's going on in the equation. So this guy over here is equal to square root of 2 over square root of 1. Oh, that is square root of 2. That is around 1.41. What we're saying is that the new period is around 1.41 times the old period, the original period. So we have not doubled the period. We have increased it, so it's not going to remain the same. The answer that we get is it's between t and 2t. And in fact, if in a free response question, they would probably want us to be able to say, oh, it's about root 2 or 1.41 times the original period. So notice how I've shown enough work here where if I just add a couple sentences of explanation, I've answered a free response question as well. Now, let's try a different take on this. If we change this question around, again, when they tell us about the fact that it's a pendulum and they're talking about period t, we have to bring to the table already that, oh, I know that the period of a pendulum depends on L and G. In other words, I'm going back to the same equation. And I have to know what to do with it. So let's just do the same quick analysis. First, did period go up or go down? Well, this time, period, hey, it's alone, and it's still the key unknown variable. Period's alone. And G, it's in the denominator. It's across from period, and it's in the denominator. This is an inverse relationship. And we've gone to a gravitational field with a planet with a gravitational field strength 2g. G went up. And so we should be able to immediately say that just looking at this equation, G goes up, period goes down. It does not remain the same. It didn't increase. It's one of these. It either was cut in half or it's somewhere between 1/2 t and t, which is still decreasing. Okay. Well, next step, we can use the same fill in the blank. And so many students, so many smart students that I know, answer these so quickly. And if you just slow down a little bit to just test it for yourself to see, you'll give yourself a better option. And since the test this year is all free response, that's just a good idea anyway. So when I look in here, this time, length has remained the same. They haven't given me anything to indicate that length has changed. But G has doubled. And so, what's the new ratio? Well, square root of 1 over 2. That's 1 over root 2. And when I put that in my calculator, it's 1 divided by 1.41. 1 divided by 1.41 is around 0.709. So, in other words, our new period is about 0.709 times the original period. So, it's less than 1t, it's more than 1/2 t. And to be specific, 0.709. So we can do some really quick analysis and answer questions like this and show when I change one variable or even change more than one variable at a time, we can quickly, for ourselves and or for answering or justifying, we can provide a nice piece of evidence. All right, come back for the next video to see what happens when the equation is not nicely rearranged, and we'll also end up talking about how do we do this with actual numbers. Sometimes students are perfectly happy with coming up with this. They can do the fill in the blank, but when all the answers then are numbers, they don't know what to do. So we'll talk about that.